Good day, everyone. This video is made to explain the purpose and show the working of the Arduino Solar Tracker. In addition, at the end, it will show an example of the project. In the beginning of the code, it sets the pin numbers and initializes variables for which the value can change over time. In this case, JSX and JSY are the variables. Void setup is used to establish serial communication and set pin modes so the Arduino can determine the behavior of the pins used. Void loop is used to check if the override switch is on or off. If it's on, it will use the override function, and if it's off, it will continue with the solar tracker automation. The compare values function is used for automation. At the top, it declares variables which will be used in the switch case function, and the following four variables will be the analog readings of each panel. The first if statement is used to determine whether the panels are in adequate lighting or not. If it meets the conditions, it will use the code within. The following set of if statements are used to compare the values between panels on the same axis. Depending on the conditions, it will change the value for the variables stated above. Using serial print, it allows for the readings to be read in the serial monitor. Using the switch case function, depending on the value, it will attend to the corresponding case number. In this instance, we use two switch case functions, one for each axis. In each switch case function, there are three cases, one to extend, retract, and stop. The break command allows it to exit the case once the preceding functions are completed. Since the bottom and right panels are the last panels to receive light, when they're within a certain working range, it will retract the X or Y axis or both. Once all values are below a working range, both X and Y axis will cease operation. By creating another function, it can be called upon in void loop. In this case, the overdrive function was created. The variables JSX and JSY are used to read an analog voltage value and create a reading between 0 and 1023. A joystick consists of two potentiometers, one for the x-axis and another for the y-axis. The if statements are used to check the position of the joystick. Depending on the conditions and position of the joystick, the actuators will have three functions: extend, retract, or stop. For either axis, when the value is less than 100, it will retract the actuator, and when it's over 1000, it will extend the actuators. And for any reading over 100 or less than 1000, the actuators will stop. These functions are used to operate the actuators. The six functions are used to create three functions per axis: extend, retract, or stop. By writing a pin high, the opposite pin must be low. For example, when writing an extend pin high, the retract pin must be low. This is because, without writing the other pin low, it can overwork the actuator and the Arduino. Moreover, without writing the opposite pin low, when that function was called before, it would continue in that direction. With that being said, in the same example for when the retract pin was declared high without being declared low after the function, the actuator would continue retracting because nothing was telling it to turn off or go low. This is the schematic for how the Arduino is wired. All the solar panels are connected to analog inputs, and they also share the same ground. The joystick X and Y axis are also connected to analog inputs, and the joystick and switch get 5 volts. The joystick needs 5 volts as reference, and the switch needs 5 volts to read as high. The relay board is actually placed on top of the Arduino board, but in this instance I decided to place it beside for simplicity. For all 4 relays, it does the same thing. When the corresponding pin is written high, the respective relay common switches from normally closed to normally open. The relay board works as follows. Pins 4 to 7 control relays 1 to 4 respectively. That being said, pin 4 is relay 1, 5 is 2, 6 is 3, and 7 is 4. The actuators are connected to common because depending on which relay is active, that will dictate the direction of the linear actuator travel. Since this project is using 12 volt actuators, we must use relays and an external power source to operate the linear actuators. The biggest challenge I faced was trying to overcome the small but many bugs in the code. During the course of this project, I learned how to think and problem solve both logically and sequentially. By doing so, it enabled me to broaden the extent and understand the steps taken in diagnosis.